Hi everyone, thank you for coming to my talk. My name is Olivia Quinet. I work in the R&D department of Clupons, and my role is mainly to industrialize algorithm developed by our statistician to analyze clinical data that are collected in clinical trials. And today the subject of my talk is apply modern C++, the problem of messages versioning in API. So the content of the talk is an introduction of what is the problem for our case, the use case that I wanted to show you. I hope you will find some maybe connection with your work, and yeah, we can discuss any input or question that you will have later. Then I will speak about the rationale behind upgrading and downgrading message version. I will show you two solutions that I came up with. A first solution that was developed several years ago in C++11 that was based on the curiously recurring template pattern. And a second solution that was developed last year in C++17, which use modern C++ with stud variant and stud visit. I will also do a small live demo. I hope it will work. And I will conclude with what I learned during this project. So the API versioning problem. So you all know, but it's good to refresh or have a common understanding. So API stands for Application Programming Interface. And in the context of APIs, the word application refers to any software with a distinct function. And the interface between softwares can be thought as a contract of service between two applications. Oh, sorry. This contract defines how the two communicate with each other using requests and responses. So small graph, on one side you have the client. It sends a request to a service endpoint, and the service endpoints send back a response. So it is a call, and is done via messages that must be understood by both sides. So therefore, we need to have a clear understanding of what are the version of the client, the service endpoint, and the messages. So this is our use case. So we have on production, we have a backend written in Python, which has a specific version, and is calling a C++ executable and this C++ executable is responsible to perform different statistical tests on clinical data. And the communication between the two is done via a JSON payload, which has a specific format. And of course, because we work with clinical data, everything must be QA approved. So, yes, and that works fine if it stays like that forever, but you know, life happens, and so we have changes. So, for example, one of those changes, it's a bug fix on the C++ side. So we need to change a version of the executable. Fortunately, the payload doesn't change, the backend doesn't need to change. So it's fine, that's an easy case. And if you want, I don't know, sorry. Sorry. So yeah, we were here. So that's what I wanted to go. So if you represent that in terms of timeline for the production, for the dev team and for the R&D team, so in production you have the 3 version, 2.7, 1.3, 2.4. We work in R&D, we do a bug fix, we give a new version, then it's QA approve, got this final version, it's pushed in dev, then it's staging, and then we go back in prod. So another use case is, for example, the backend needs a refactoring, and that refactoring also needs a change in the JSON payload because it's easier for the Python program to have that the name are changed in the JSON. So we have a change in the backend version, a change in the JSON payload version, so go from 1.3 to 1.3.1. And of course, the executables need to change too, so to adapt to this new JSON payload. So we have that. Sorry, I'm going to the PDF, the backup version. So in terms of timelines, so in production is the 3 previous versions, so 2.7, 1.3, 2.4.1. The dev, they are starting to work on 2.8, but when they start working, it's still 1.3 for the payload, and the executable is 2.4.1. So we work in collaboration inside R&D with the dev to have agree upon the new payload version 1.3.1. We do the necessary development, got qualified, and then the dev can use it. But at this stage, in fact, some part of the component of the dev backend still need to use the 1.3 because they're not yet ready to use the 1.3.1, but they already want to have the new executable. So that means that we have to support at the same time 1.3 and 1.3.1. So that's a bit more complicated than previously. And then when everything is done, again, it goes in staging and then goes in prod. This is another use case. For example, we have a new feature, a new test, statistical test that we want to put in production. So means that we need a new C++ executable. So for example, version 2.5, a new JSON payload because we will introduce new keywords in the JSON, so new version. And the backend, if you want to use this new version, needs also to be updated. So, for example, 2.9. So, in terms of timeline, we have this schema that I guess now you are more used to it. So, we work on the new feature, get QA approved. The dev, again, have to work at the beginning with the previous version of the C++ executable. At one point, they start to work with the new version. But again, not the whole thing is going to switch directly to the new 1.4 format because they're not yet ready or they don't need it directly, but at one point they will. So it takes time to propagate everything. And so we still need, again, to support at least 2 versions. So at the end, it goes to staging and then to prod. So, that's a summary. So we have in production, a backend with a new version, a C++ executable with a new version, a payload with a new version. But also, for example, for this time, we introduce a subcomponent which has also its own version. This subcomponent is, for example, a post-processing for the statistical test, and it can be applied like in a pipeline, but it will have also its own version because it makes life easier. Because if you have to change the whole payload, version of the payload, whereas we just want to update this pipeline subcomponent, it's getting really messy and it just increases a lot of the version changes just increase and it's quite maintainable at the end. So a summary of the API versioning problem. So first point, we have to support several API versions, at least 2, sometimes more. And this is because there is different time frame for the release of that can be used in development and in production or even in parallel environment. But that can be solved by using, for example, the green-blue deployment pattern. So you have just one version of the executable, and you have when you are ready, you do the switch. Or another point is you have only one executable, but the endpoints can be called with different API versions. So I'm a client with a certain version, I want to communicate with the backend with a certain version, and I expect the response with this version, because I don't need to use the new version. So in the green-blue deployment, for example, you have to maintain different versions of the executable, so one that support one version 1.3, one that support version 1.4, but then you have bug fixes that you have to put in 1.3, 1.4 at the same time, so it has some advantages and disadvantages. And the other solution is to have only one executable that is the same with all the environment, but it supports the different API version. And that is what we decided to go. So the pros of this approach, you have only one code branch to maintain. So you don't have to backport bug fixes into different branches and different release. And also, for us, it's quite important. It means that we have only to qualify one executable and not different version of the executable, because I told you it's a clinical, pharmaceutical environment, so we need to qualify everything. And we have to document everything at every time of full folder for a new release. So we want to simplify that part too. And the cons, it's so we have a complex, maybe a more complex implementation, because we have to support inside the same executable different version. But the real question, is it really more complicated or not? So, and now I will speak about one of the approach. It's about upgrading and downgrading version messages. So, in fact, we have one client, for example, as I say, you want to send a request in version 1.3 in the service endpoint, which in fact is already supporting version 1.4. So what you should do? So the approach we took, it's we take the request in version 1.3, we upgrade it to version 1.3.1, and then upgrade to version 1.4. We do the computation with all the bug fixes and everything in 1.4, then we downgrade the response to version 1.3 so that the client can understand our response. So, is there any problem with this kind of reasoning? For example, we have a minor change in the version. So that means, for example, a field has been renamed or moved. That doesn't really matter because the content is still there with the same meaning. A field is added or removed, or maybe you can use a default value for that additional field that was not present, for example, in 1.3 when you do the migration to 1.4. Or here, it should have been a green mark. And so, yes, most of the time for minor version, you can use a default value, would not cause any problem. And for example, if a value has been renamed, for example, it goes from 1.0 to true, false, or yes, no, so it's the same meaning, but the meaning is the same, but the string representation is not the same, so you can do a conversion, or the worst case, maybe use the default value. If you have a difference for major differences between version, for field rename and move, that doesn't cause any problem. If we have an added field or remove field, in this case, it might be more problematic if you have to use the default value. Same for when a value is renamed, added, or remove, it might cause a problem. So it might cause breaking changes. And so those breaking changes are important to consider when you design the new API. And you have to know the risk behind it and to know if it's acceptable to have those breaking changes, or if you can mitigate them, or if you say, no, I can't do the migration between 1.3 and 1.4, and so it won't be possible. So it's everything that needs to be discussed with the teams. So an example. So for example, the input version 1.3 was something like that. So you have a field with the version, and then there was some kind of group called webconfig with a job ID, analysis ID, and a grouping type. And after the refactoring, instead of using camel case, they used the underscore notation. So of course, it's different version. If you don't do the update, it won't work, but here just simply matching. And also the grouping tab has been moved outside the web config group. So in the C++ executable, you have a read 1.3 version and a read 1.3.1, and it's filling structure input 1.3 and 1.3.1. In fact, it's more or less the same, and except the grouping tab has been moved. So when it's reading, it's filling this structure. Same for the output, except for the output in this case, in fact, there was no difference between 1.3 and 1.3.1 for the output. It's just a way of formatting. So job ID has been moved to ID, simply. So implementation. So the first solution was using the curiously recurring template pattern solution. This is a screenshot of a CPP reference. So you have a base class, which is a template, and the T is referring to the tip of the derived class. So that base can access the members of the derived class directly. It's a kind of static hierarchy instead of having the dynamic inheritance with a pointer. You have everything static, everything is node and compile time. So it's great. And in our case, it was used this way. So we had a version base with some common quantities. And it is the CRTP part where you have the version, the version you are going to implement. And the previous version is the type of the previous version. Version in this case was an element of the enum class version. But you can find the derived class because everything is defined like this. So we have version 1.3, depends on, of course, version imp the 1.3. So this goes from there. And you define a shortcut in C++11. So it's easy. 1.3.1 is 1.3.1, depends on 1.3, and so on, and 1.4, and so on. So that was fine, but so it was a C++ solution. So at that time I was migrating from C03, so that was quite a change. It was nice. It was quite straightforward. But of course, it worked for several years without problem. But when we migrated to C++17, there was new way to do it. So, and yes, so it was we needed a new solution. And of course, with that, there was quite a lot of boilerplate because for every part of the application that we wanted to use this type of pattern, we had to recode a lot of things. So it was not really easily reusable framework, and it was also lacking some flexibility in the case, for example, that you have a bug fix that you have to put in production. So 1.3.1 goes 1.3.1.1, but you are already working on 1.4, then you have to put the bug fix 1.4.1 because it was not possible with this type of structure to represent this type of complexity. So when we switch to C++17, we use stud variant and stud visit. So brief summary, so stud variant, it's a class template that represents a type-safe union. So we just read, but as with union, a variant holds a value of some object type T. The object representation of T is allocated directly within the object representation of the variant itself. The variant is not allowed to allocate additional dynamic memory. And to have consistent behavior of union during aggregation initialization, a default constructed variant holds the value of the first alternative if the first alternative is default constructible. And stud visit. So stud visit apply a visitor this, which is a callable that can be called with any combination of type from variant to the variant in this list. So now I will present you the code, and it's I will start from I will do a top to bottom presentation. So this is the end, the very more abstract layer of the code. So we have all the versions that are gathered here. We specify the latest version. To read an input stream, we define a read function. We use the read function from the versioning, the variant versioning. If we cannot read it, we throw an exception. And then we have to convert that data that we read to the latest version. Same for the write. So we have the write. We want to output it to an output stream. We want to have a specific version for the output. We have the output data in the latest version. We first have to convert it to the requested version. If the converter was not okay, we throw an exception, and then finally we write it. So that's quite straightforward. It's code you can understand directly. But for this, we need to define each version as a type. So, for example, we have struct v1.3. We defined what is the input data and the output data. They can be defined somewhere else. So, and we have to define 5 functions. First one, version, which returns a string view of the current versions, for example, 1.3. We have a check version, which check the content of a string if it's matching version. We check if an input stream will match version 1.3. And we read an input stream, and it will return an input data 1.3. And we can write to an output stream output data 1.3. And as you can see here, we separate data from I/O operation. So we respected the separation of concern pattern. So we have the data and the output. So, and in fact, the input and output stream can be anything you want. For example, it can be JSON, it can be socket, it can be file. So it doesn't matter. Your data are not dependent on the I/O operation. You can define them separately. So I use for inspiration the type sequence from the talk of Andrei Andreescu from CPPCon 2021, embracing and also destroying variant. So the variant versioning, it's a variadic template here. And inside we define 3 variadic template version, which is simply a stud variant of all the struct with the version that we want to play with. We have the input data and output data variant for all the version. And we have a version function that will give you the actual version of the actual version that is contained inside the version variant. We want to check the input to give us which version is inside the input. We want to read from the input stream, and we want to write to the output stream, the output data that we have. As you can see, for the moment here, we don't have any specific version, so we just have variants. So very generic. But we also want to convert input data from one specific version to another. So the first parameter 2 is the output version that we want to convert the input data from and to. Same for the output. For the output, we have 2 versions of the method output 2. The first one, we want to specify the output version as a string, and the second one, we want to output to a tab-defined version. So we specify the first parameter. For example, we want to output it to version 1.3, 1.3.1 in the code, so directly. Now I will go into the implementation detail of the check function. It's so this is the check function, and simply return of the check input method of the input string with all the instance of the version, variadic version from the main template. And this is the specialization. So it gets, it's a meta data, it's a meta programming somehow. So we'll take all the version here in these parameters. We check for the first one if it meets it, and then if so, we return it. If not, we go to the next one. And the latest thing is to simply return, when there is no more version to check, he returns the null optional. To get the version is quite easy. So we have the variant with all the version, and we apply a stud visit to it, and it returns the version that is defined inside the structure for the version. Yes, so now I'm going to switch to the reading an input string, and we want to return the actual version data structure from the input stream. So we have an input stream. We have first to get the version, so apply check. If we have a version, we read the version. We call this method read version from the input stream and the version that we found. Otherwise, we return the optional, the null optional. And with version is again very easy, simply applying a standard visitor to the method read for the version that we have found. And now to convert some data from one version to another one, that's a bit more tricky, but in fact it's quite straightforward. So 2 is the version I want to convert to. And first defining the 2 input data, which is simply the input data inside the version. And we apply a visitor to the from input data. And the first case, if we have exactly the same type from the input data and the 2 input version, then we simply forward it. Otherwise, we try to do a conversion if the conversion is defined. So this is a context if. I will go to this function a bit later. And if the conversion cannot be defined, we throw a runtime error. And so this is convert function. It's a structure that uses substitution failure is not an error. By default, is false and is defined only if there is inside the 2 version a convert method that can accept a specific argument. And we have a helper variable template is convert define v that takes directly the value to true or false. So that means that input data you have to have a convert method that takes some input and do the transformation. So for example, for 1.4 you can convert from 1.3 input data, and then you do the magic there. And for everything else, but you go back to the previous version, 1.3.1, you call convert, and in this case, well, if you don't have it, it won't compile, so you will get an error, or you can also handle that with an exception. And writing to an input stream is about the same, so we have write, output stream, and we have the variant with the output data. We take the index of the variant here, and in fact what we are trying to find is the associated version. So we have input data in a certain version, but we want to find the version. So we have to, if you remember at the beginning, we have first a variant with all the version, and then a variant with all the output data associated to each version. So we have to go back. We have to traverse the two. And yes, that's metaprogramming again. And once you write it, we call the write function of the associated version. The conversion is about the same as previously. So we have a specific version in string. And we are going to try to find the corresponding type for the version. So we have to check it. And if you check it, means that you have the version. So you do an output to with a specific type, you forward it. And if the conversion was okay, you return it. Otherwise, you return the null op. And then if you do it for all the version in your sequence of version that is defined at the beginning. So, and it is the second part of the output too. Now we have the type. And if it's the same type as the as this parameter, we simply forward it. Otherwise, we try to find a convert function that will match our parameters. Then we call it. Otherwise, we return the null op optional. So that means that for the output data, you need to have some convert function, template convert function, that you can define at a different stage in your application. And so by default, it can return a runtime error, or that means that if the type is not defined, you will have an exception. If you define if you specialize this template for a specific version, you can do the conversion magic there. So now I will switch to the demo. No, c'est là. Okay. Can you read the screen correctly? Or is it too small?
Up front it's fine, but I suspect you can.
Okay. So this is a Compiler Explorer, and it's a CMake project inside Compiler Explorer. So I have different file, versioning.hpp, which is more or less the whole code that I show you in the slide, but with some additional debugging information. So we will be able to see what's happening in the code when we will run it. API is where you define all the versions you are going to use. Here we have two versions that's been defined for the demo, 1.1 and 1.0. We have the read and the write function that has been presented in the slide. We have the two versions, so 1.0. So here, for the simplicity of the demo, we simply have for input data, output data, a version with a string and a payload and some convert function. And we have here the 5 methods I told you about before. So we have version, check of the input stream, read, and write. So version is we simply have v1.0. For the check is simply a check of string. When we want to check an input stream, we are going to check if there is in the JSON a component called version, and it must match the version we are currently working on. For the read, we are going to construct an input data and simply load the payload from this member, so payload 1.0. And for the write, on the output data, we write the version and we write a payload. But of course, you can imagine that the payload can be anything. It can be heavily processed data. So, yes. And for 1.1, it's about the same. So we have a version, a payload, default constructor. Here we have an explicit conversion operator, so which take input data from version 1.1, and that's where the magic of the conversion between version happens. So, and here, for example, to show that it's been there, we simply take the payload from the 1.0 and we say it has been converted from 1.0. And so, yeah, and the convert function simply call this explicit conversion. Output data is the same, so we have the template convert that will be defined a bit later. And again, we have the 5 functions, so version, check read, and write. And so here we define all the conversion, all the allowed conversion between 1.1 and 1.0. So by default, they cannot convert, but here we define that, in fact, we can convert from 1.1 to 1.0, or to 1.0. Okay. So, and the main, so this is very simple. So, for example, in this case, we define a payload in version 1.1. So payload 1.1 contains world. We want to read version 1.1. So we will print the content of what we have been reading. We want to put something to 1.1. So we're going to dump the content, and that's it. So, and if you, it's already been executed, so you have the output of the program here. So in fact, here it's checking version 1.1, so the first call to check. So it's 1.1, okay. So I'm reading 1.1, and at the end, so we have input 1.1, and what we put in the payload, which was world. And for the output, okay, we have 1.1, and we write it into 1.1, and at the end, we have the expected payload. So payload 1.1 with hello world, and version is output 1.1. So that's easy. And now, I open it up. We are going to read payload 1.0, and we want to put to 1.0. So it's compiling. Okay, it's done. So here, the output is a bit changed. Of course, it's checking the first version, 1.1. Then doesn't match. Checking version 1.0 match, we read it. So version is 1.0. And in fact, because we wanted to work with version 1.1, we have to convert from 1.0. That's what we saw. And now we want to do an output to version 1.0, but from 1.1. So we have 1.1, no, yes, for 1.0, writing version 1.0. So payload 1.0 convert to 1.1, so hello world, and the output version is 1.0. So that's about the end, and yeah, okay. Don't know if you have question on the demo or something. Okay. Yep. Yes. So now what is summarize what I learned. So first, of course, when you try to design a solution, you have to think, you have to try, you have to test, and in fact, even if you have a good working solution again, and the first thing you have to redo it because language, the C++ language has made some progress, and so it's possible to solve the same problem in a much more easy way, in a much more effective way, and so that's why it's quite important to keep informed about the language specification and what you can use. So thank you for your attention, and if you have any question, I will be happy to answer.
Hi, thank you. You have one struct per version.
Yeah.
And if I understood correctly, well, in your demo, you had a very simple payload, obviously.
Yes.
So in a real production code, the payload would be much more complex.
Exactly.
Now,
yes.
let's say, okay, from version 1.3 to version 1.4, let's say 90% of the payload stayed exactly the same, and there's 10% that you changed.
Yes.
Now, would you copy everything from the type version 1.3 to type version 1.4? So you have basically frozen the code for version 1.3? Or would you share code between versions to reduce code bloat, especially if you get a lot of versions that you want to support?
But for the structure, I keep them the same. I don't change back version 1.3 to fit version 1.4.
No.
Yeah. I still have everything associated to version 1.3 for reading and writing stayed there because I still need them.
Yeah, but if you say, okay, version 1.4 is almost the same as version 1.3, there's just a few changes.
Yes.
So do you completely redefine the payload for version 1.4 from scratch, even if it looks almost the same as version 1.3?
Okay, but for reading, you may if you write it correctly, that's what we try to do. We decompose the whole reading approach into several static methods, and so they can be called between versions. So if you're initializing one part of the component, one initialization of the payload is the same, then yeah, you can reuse that code.
So you would use these versioning structs per component, and one component could be unchanged and the other could have a new version interface?
Yes, for example, yeah, I think so. Yeah, if I understood correctly what you mean.
Okay, it's a complex topic. Thanks.
Yeah, it's a complex topic, but here I didn't stress, but for example, if you have the data in version 1.3 and when you want to migrate it to version 1.4, I try to also avoid memory copy. I try to put everything with move, so that if I can extract some information from the input data 1.3 and stay the same in version 1.4, then I simply move them. So the whole, if it's 90% the same in memory, then I will keep it. Just move it from one structure to the other one. But the reading will be done in 1.3, yes. So in the end, the output of reading in 1.3 is input data version 1.3. And I want to migrate that data in memory to 1.3 to 1.4. If there are some common parts, I simply want to move that common part to 1.4. And the part that needs some conversion, of course, I will need to create a new data structure in memory to do the conversion. But if there is no conversion, I can move it directly. So I made no copy in memory for what I do, what doesn't change. I don't know if that answers your question or if it's. Yeah, we can discuss specific case. Yeah, but I say that is our use case. In my create question for you, we might bring you some hints of what can be done or not done, depending on your use case, of course.
The users of these new versions, are there then also copies? Imagine you have your version 1.3 that has some kind of logic attached to it. In a service, it's being used.
Uh-huh.
And then you have version 1.3.1, which is just a minor change.
Yes.
But the type is completely different. Do you template this then in the users, in the services, or how do you deal with the different types flowing through your service?
Yeah, so I am on the server side, I would say. So, yeah, in fact, we had at one point some change of logic between two versions. And yes, that was creating some differences. But it was decided that everything will need to be done in the latest version. And so, in fact, even if the client will call 1.3, he will get the updated result from 1.4, but presented in 1.3 because that was expected.
Okay. Yeah, you always
Because it was a
convert
better
to
answer.
You always convert to the latest version.
Yeah.
Okay.
Yeah, because if you wanted just to keep the same, let's say, not faulty response, then you can just keep the same executable, but then you don't get the bug fix and the improvement. But what we want is to propagate the bug fix, to change the improvement, even in previous version.
Okay.
But of course, our use case is maybe limited, and it's nice for that because you always want to have the best result for the statistical test. So you don't want exactly the same result because you know they are missing something. So you can say to the client, even if you use a previous version, you will have the updated result anyway.
Maybe a bit of a naive question.
Yes.
So I understand that you try to serve clients that talk different versions.
Yes.
And you said it's mainly for your integration environment.
Uh,
Or is this also something that happens in production on your
Yeah, but
business?
in production, the problem is you have different version. For example, we have the production environment, of course, that use not the latest version, but the one to previous.
Yeah.
And somewhere we have also a demo where client can use the latest version. So, but we don't want to maintain everything, so we just put the latest executable version there. So, because we know there is bug fixes and better result and everything. So, so yes, we need to support different version of the API.
What drove your organization's decision to do this in one server version rather than just running two server instances in parallel that have different versions?
Yeah, yes, that was discussed, and that was the blue-green, something deployment or whatever you want to call it. Because at the time we were a very small company, and it was hard even for the SRE team just to maintain different environments, and so it was much easier if they would have just to pick the executable from one repository. It would be always the last one, and it's easy. It was also a discussion of, say, to ease the job of some of the teams.
Okay.
And also, because we qualified that version is the latest one, and so it's easy. Because otherwise you have to qualify also the whole application with one version and then another version, and it's just create a lot of problem.
Okay.
But yes, it's a trade-off between QA paperwork and easiness of development and use.
Okay.
And,
Thank you.
So, thank you.
Thank you. Short question, do you employ things like semantic versioning to keep the number of versions that you have to support at a minimum?
No.
Then I recommend you do.
Yeah, well, for the moment, we are supporting everything from the beginning. So just, we can do some code cleanup too at one point because the very first version are not used. But in this case, we need to make sure that we don't call some reading function from version, for example, 1.0. We just have to duplicate to extract the code from that one. So, yeah.
So you just mentioned that you basically kept all versions active since the beginning of time, more or less.
Yes.
What's the strategy with your example you showed earlier where you have this branching version numbering? So where you have your hotfix in production you need to roll out, but you're also introducing a new version. Which path are you taking?
That usually the very small one, I don't take it.
Okay.
Because there is no point of, there is a shorter path. You can implement that logic directly in the code.
Okay.
Yeah, so. Especially with the latest version of the code, you can decide from which version you can do the conversion. So it's a bit more flexible. You can do whatever logic you need and to respect the business logic.
Hi, thanks for the talk. A bit of a follow-up question
Yes.
in the same logic of the guy. What are the semantics of versioning? Like, what can be in your example? What can be a patch? What can be a minor?
Oh yes.
I didn't really understand the
Okay.
problem
Yes.
there.
The first number is the major version. So second number is a change. For example, when you introduce the features, a new feature.
So can a breaking change in API behavior in your company,
Yeah.
in this product, can it be part of a minor change?
A manual?
A minor change.
Not really. We try not to do. If it's a breaking change, then we want to update the version number, the main version number. But you need to be consistent internally, and it's quite hard. It's not always. Yeah, that's the whole subject of versioning, choosing the right version number.
Yeah, because I think the whole room was a bit okay. She's renaming this variable, but
Yeah.
it's only a patch.
Yeah,
How does
yeah.
this work?
Okay.
Maybe we can talk about this.
Yeah,
after
yeah,
the
but,
time,
yeah. Okay.
Hi. Yeah, thank you for the talk. So my question is, so I understand that you kind of build the conversion chain from the latest version all the way until the first one, right? Like in this convert
Yes.
chain. But did you think of like making a shortcut from like version 4 to version 1, if like to skip intermediate
Yeah, yeah, but
conversion?
you can do that. Yes.
And then, and the second question is like, if you do automatic like major, if there's a major chain, you know, basically split the version number into like major, and then let's say automatically break that there is no conversion from major version 2 to major version 1, because like, you know, this API break or whatever, you cannot maintain this.
Yes. Yeah, but it's possible. It's possible. You can do with the latest version, with the convert. You can specify, for example, a runtime exception that say, okay, I can't convert that.
Manually, you mean?
Yeah, in
okay,
the code, yes, but
okay.
you have to, you have to specify how you convert. So, for example, in your case, if you implement the conversion from 1.4 to 1.0, and you have a function that does this as this matching signature, it will be taken.
Yeah, but for shortcut, I was meant like, let's say you have client wants version 1 and you have version 4.
Yeah.
And then your version 4 has like, let's say you define conversion to version 3 and version 2, but
Yeah.
for version 1 it will still go 4, 3, 2, 1, but instead of 4 to 1, right? Like this.
Yeah.
It will not pick the shorter path even though it exists.
Well, yeah, it's not always the case, but if you want to have the shorter cut, it's possible to do it. Otherwise, yes, you delegate to the previous version and so on and so on and so on. But if you want to specify a shortcut, you can do it.
Yeah, thanks.
So it's flexible.
Hi, thanks for the talk.
Thank you. Yeah.
My question is, as I understand, you always go through to the latest API, and then, well, once you process it, you go back to whatever the output is required, right?
Yeah.
What about the cases where it doesn't make semantic sense to do that, from going from one version to the other? I don't know, let's say there's version 1 and there's a response 1, right? And then there's version 2 and response 2. And they can be, let's say, through different paths. Internally, you have different logic to handle that, and there's responses to that. But it doesn't make sense to go through this chain.
Yeah, but that may be your use case. For us, it's very important to have the latest response for the output of a statistical test. So if we update a test, So it's very important that the user see the updated value, even if it's using a previous client. But that's our use case. So,
Okay, so you force the client to upgrade to the latest version.
no, it doesn't need to communicate with the latest version, but he will get updated result even if he doesn't upgrade his version. So yes, the output will be different because he will have some the latest version of the test, even if it's not called directly. So
Okay.
I have a question around, so aside from the interesting payload that you transfer between clients and collectors, do you do any handling for telemetry or logs? And can you distinguish, if you do these progressive schema transformations, can you distinguish live distribution of existing legacy versions out there?
sorry, no, I don't understand correctly what you want to say. So can you formulate?
Can you first of all, are you doing any collection of telemetry data or logs from clients?
Nope.
Okay, so that's out. And then can you distinguish, for example, do you have any plan on sunsetting particular very older versions? Can you distinguish if you have a version distribution among your user pool? If you do these transformations and always upgrade and downgrade messages that you transfer, can you still have a clear picture of the pool of existing users? For example, how many are in version 1.3?
Oh, yeah, if you want, yes, but that's not really relevant for our use case.
So it's not a goal for you to...
No, not really. But in fact, in our use case, what takes time is the computation. So it's not really the reading of the data or anything. That's not even 100% of the whole time.
Okay.
So
and you don't have like an objective of eliminating support for a particular range of version at some point?
we can decide that, but for the moment there is no need. So yes.
Okay.
Yeah, it's best if everyone upgrades to the latest version, of course. Yeah.
Okay, I seem to be the last person. I just wondered, you were mentioning downgrading and upgrading, but
yes.
It seems that in your code you just have convert, so you don't explicitly label a conversion as a downgrade conversion or an upgrade conversion. And
no,
is that deliberate? Is that better, or is it? Does it not matter?
I think it's the naming problem. I like the word convert, is short. Whereas upgrading, downgrading is, it's a bit longer to type, and yeah, I don't know.
Okay, thank you.
Yeah, okay. Well, thank you. On time.